Hey guys, this is practice for 7-1. It's problem number 2. This one's not actually calculating a point estimate or a confidence interval. It is asking you to find the sample size that you would need. Okay, so for this one, you're going to use the formula sheet. If you go down to the bottom of your formula sheet, you'll see determining sample size, finding the sample size required to estimate a population proportion. The requirements are the sample must be a simple random sample of independent sample units. Now there's two different formulas depending upon whether or not you have an estimate for your p-hat or if you do not have an estimate for a p-hat. Okay, so you'll use whichever formula is applicable to that particular problem. The main difference is if you don't know p-hat, you're just going to use the 0.25 here in the formula instead of p-hat times q-hat. So that's basically the biggest difference. Okay, so find the sample size needed to estimate the percentage of Virginia residents who are left-handed. Use a margin of error of 3 percentage points. This is that capital E from the original problem number 1 up here. This is this capital E that we're talking about, margin of error. So in this particular problem, we want a margin of error of 3 percentage points or 0.03. And we want to use a confidence level of 99%. Now, the first problem, we used a confidence level of 95%. Okay, that meant our alpha was 0.05. And then when we split that in half, that gave us 2.5% or 0.025. So down here, if our confidence level is 99%, that means our alpha is 1% or 0.01. And then when you split your alpha in half, that gives you 0.005. Okay, so the z sub alpha over 2 that we need in our formula would come from StatCrunch again. So we want the z sub 0.005 or sub alpha over 2. Okay, so we could get that critical value. It's 2.576, but let me show you where that came from. So we're going to come over here to StatCrunch. We're going to go to Stat, Calculators, Normal, okay, and z sub alpha over 2 was z sub 0.005, so we're on a standard normal distribution curve here, so the mean 0, the standard deviation is 1, and the z sub alpha over 2 is the area to the right is what we're looking at, so make sure you've got the greater than, x is greater than, and the area is 0.005. That was our alpha over 2. So that gives us our critical value of 2.576. That's where that came from. In case you're wanting to figure out where that came from, that's where this 2.576 came from. Okay. Now, when we come over to part A, let's assume that our sample proportion is unknown. So let's assume that we do not know p-hat. So we would use this formula. We would use this one with the 0.25 over here. Okay. All right, so let me go back. All right, so we're going to use this formula. We're going to type in 2.576 for the z sub alpha over 2. You have to square that, and then you multiply that by 0.25, and that whole thing is to be divided by your margin of error, which in this case is 0.03, and you square that. So be real careful with your calculator. If you're typing this in all at once, be careful. Make sure you group your numerator and you group your denominator so that you don't have any issues there. Okay, now what they always want you to do when you're looking for a sample size, you can't have a sample size of 1,843.2 or 0.271. So they always want you to round up for sample size. You'd rather your sample be a little too big than a little too small. So you're going to round up no matter what. And so your sample size in this case would be 1,844. Now, let's pretend that you do know p-hat. Let's pretend like you do have a sample proportion. And based on prior studies, about 10% of Virginians seem to be left-handed. So if you want to know the sample size that you would need to estimate the percentage of Virginia residents who are left-handed, you would use the 0.10 for your p hat, or your sample proportion, which means your q hat is 1 minus the 0.10, or 1 minus p hat, and that gives you the 0.90. And those are the two numbers that you can use in, let me show you the formula. So you'll use this formula since you know p hat. Okay, you've got an estimate of p hat. So you'll use this formula. So that's what we plugged in here. So n, our sample size, equals the 2.576, which came from over here. You got to square that, times your p hat, which is 0.10, times your q hat, which is 0.90. The whole thing divided by your capital E, or margin of error, which is 0.03, and you're going to square that. And when you do that, when you type that in your calculator, you'll get 663.5776. And again, you want to round up. So your sample size in this case would be 664. I hope this helps. Thanks.